Thank you. Bonjour, hello. We're here from Northwestern Mutual to talk a little bit about Intel as Code. My name is Chris King. I'm the Senior Director for Cyber Threat Operations at Northwestern Mutual, which, if you're not aware, is a Fortune 90 insurance company out of the US, based in Milwaukee, Wisconsin.
Hi, everyone. Matt Lange. I'm the Assistant Director of our Adversarial Security Testing Team, which is just an overly fancy way of saying I manage our pen test and red team and purple team.
So we're going to start a little bit talking about cyber threat intel reporting. Generally, we get our intel from a bunch of different ways. I have an intel team. A lot of organizations have intel teams, or they consume intel from a provider or service or something like that. So you have your internal sources, you have your external sources, so your Mandiant reports, your CrowdStrike reports. Sometimes you have a blog, maybe DFIR report, or you're receiving information from Twitter or some other source like that. Sometimes emails or tweets as well. So how do we keep track of all this data? Maybe it's a tip or some other way of doing it, but how do you take that information and then really communicate that effectively from your CTI team to your detection teams? And how do you know that it's working? And how do you do it fast enough? That's what we're here to talk about. So some current challenges between what we see from the threat detection perspective. So on the top is kind of the high-level process for how a lot of organizations, we tried to generalize a little bit, do threat detection. And then at the bottom is kind of showing the adversary time scale and how fast it takes them to iterate on those campaigns as they occur. So if you follow I don't have a bouncing ball, but I have a red skull, so kind of the same thing. The adversary will do something. So they take an action, a campaign, activity of some sort that is detectable at some time period after that by whether your own tools, other tools, things like that. That iteration that occurs is in hours. And by that time, hopefully, one of your teams or one of your services is doing that initial collection. But by the time you finish that collection, the adversary is already on to the next thing. They're on to the next campaign iteration. If you follow Qbot, they love doing kind of the next kind of how am I going to go and execute an ISO file type of thing. So this activity keeps occurring. We're left trying to consume that original campaign and those techniques. So at least we collected some of the intelligence, but how do we contextualize that for those other teams? Do we start with taking it and having those intel teams turn into YAR rules? Do we use that to do emulation? But you have to build that. That same intel guy isn't going to be the same person to do those other activities as well. And then by the time you've gotten to the point of actually starting to do that detection engineering research, the adversary is already on their third campaign or fourth or however many, depending on the type of campaign. So high level, ideal state, we want to be able to move quickly and fast in hours. We want to be able to do it at the same pace as the adversary. We want to eliminate that asymmetry. So we're going to kind of talk about this challenge between CTI teams, detection engineering, and really bridging that gap, that red area in the middle there, to make that friction less and to allow us to move faster and at a pace that works for all the teams, but by kind of using a shared language and a shared way of communicating this information, without having to hire, the rare unicorn analyst who has all the skills of CTI, detection engineering, incident response, what have you. And just to give you an example, so on the right side, you'll see, it's your right side, DFIR report. Another example, really great example of hey, I got some good information, some good intel that I can use, but it still has to be taken and contextualized for that detection engineer. So, someone has to collect that. They have to recognize that, hey, this is fraud helper using a UAC bypass, for example, in this case. And we got to turn it into something. Well, we have, thankfully, a way to do this now, as you all probably know, that MITRE provides a system to turn some of this stuff into quick turnarounds for developing, hey, this is a technique that can be analyzed. We have a certain way of analyzing it, and that's helpful. We're trying to go a layer below that. We're trying to look and say, what's that procedure that's below the layer that MITRE provides, and can we iterate at that level? Because in some cases, we're not always seeing that easy matchup between MITRE and some of the threat activity that we're seeing. So if you're familiar with MITRE's attack framework, hopefully everyone knows, I won't go into too much detail, but really it's just a way to describe seeing the wild data for specific threat activities and then categorizing them in a way that everyone can reuse the same techniques across the enterprise. We use MITRE's technique ID numbering system for our own activities, and we basically try to map to that as well. But again, we're going to go a layer below this. We'll kind of talk to you a little bit as to why. So just one more example with MITRE here. So back to that fraud helper with a CrowdStrike, cobalt strike beacon, sorry. Although it'd be pretty funny if it was. So T1548 is a MITRE technique specifically for elevation of privilege. We're going to talk about some of the sub-techniques. So in this case, FOD helper is used for bypassing user account control, which is T1548.002. But as Matt will explain, there's more to this problem, and more to how we're trying to convert this time and make it a little faster. MITRE's made us move that analysis time a little bit quicker, but we want to go faster.
Okay, so I want to start by saying we love MITRE, we love the attack framework. We built our program around it, so absolutely love the framework. We're going to continue to use it for as long as I can see us using it. But we think it has a few problems that we want to work around to be able to make this work for us. So if we take the example that Chris gave about 1548.002, the bypass UAC example with FOD helper, we can create an attack that triggers that detection. Real simple logic, right? We're going to write a registry key to a certain spot. It's going to have data in that value spot that has points to our malicious binary. We're going to write that binary to disk, and we are going to then create a FOD helper new process, right? That FOD helper process starts, refers to that registry key, kicks off our malicious binary. That's a quick description of that particular MITRE technique. So we should be able to say that we have MITRE's UAC bypass 1548.002 covered, right? Obviously not, right? There are, I think the UAC project has 70 plus some different ways of doing UAC bypass. So let's just look at another one, event viewer, right? Very similar, if you can see that in back, I hope, but very similar technique, right? Modifying a registry key, just one of the subkeys within there is a little bit different, and then you're kicking off a different binary to kick off that UAC bypass. Okay. Are we covered? Maybe, right? We could probably do some wildcarding with the registry key. We could probably do an AND statement or an OR statement with the binary. So, okay, possibly, but we got to track that, and we got to make sure that we're getting both of those angles covered. What about CMSTP, right? Different way of using INF files, right? Referring to those. We've got, sysprep. I could list, like I said, the 70 plus different ways to do UAC bypass, right? And we see this all across the MITRE attack framework, right? User execution of malicious file. 1204.002 for screensaver files if a screensaver is malicious. Cool. What about LNK files? What about LNK files that call a command process? What about LNK files that run DLL32, right? So it's apparent that MITRE tracks tactics, techniques, and even sub-techniques, which we see here, but we had a clear need to track at that lower level of detail so that we can make sure that we are validating that our detections are able to trigger on each one of those individual procedures, right, TTPs, the procedures that happen underneath those sub-techniques. So here were the challenges for us. We needed to define procedures so that we can track the adversaries at that level. We need to communicate between all of our different teams, and we need that communication to be rapid and consistent so that we can have that communication be rapid and consistent across those teams. We need to coordinate that communication, right? So once we have that information to communicate, we need to coordinate that so that we can reduce that mean time to detection as quickly as possible. We want to convert threat intelligence into actionable emulation, detections, alerts, and hunts as quickly as possible so that we can stay ahead or at least in parallel with that adversary loop. And to do that, we're going to need to build some automation. So let's get into it. Procedures. Our definition, how we define a procedure, is a unique, sometimes tool-specific method for implementing a technique or sub-technique that demands a unique detection. And that last part we think is really important because we know this can explode on us really fast, right? There could be, it can get really big really fast with all the procedures. So we committed to only creating a new procedure if we couldn't detect it at a higher layer of abstraction. So for example, if we have 5 binaries, super simple example, if we have 5 binaries, they all modify a registry key in the exact same way, right? They create a new registry key or modify a registry key, put the same value in it. We don't care about those binaries, right? We simply need to go detect on and build a procedure for the modification of that registry key. If we can detect on the modification of the registry key, you can do it any way you want. Binaries, Win API calls, whatever you want to do, we just need to detect on that modification of the registry key. We also need a language to communicate these procedures, like specific language. So we further define procedures as a set of verbs detailing actions taken against an object described by its attributes. And I'm very sensitive to the fact that I'm up here in front of a group of IT people talking about verbs and objects and attributes. So I promise we'll get through this, it'll be simple. Here's some verbs, right? CRUD, we all understand this, right? Create, read, update, and delete. That covers a lot of what we want to do in our world. The objects that those verbs, that those actions are taken against are things like files, processes, registries, accounts, right? So pretty simple. We're going to take an object, or we're going to take an action against an object that we're pretty familiar with, and we need to describe those objects. So we're going to describe those objects with the attributes such as a name, a type, an extension, or a path. So for example, we could say we're going to create a new process, and that process is going to have a name and an extension. Pretty simple, but pretty powerful. This is a consistent set of verbs, objects, and attributes that we can reuse over and over and over again in order to describe and communicate clearly and consistently between our teams. This slide, just a quick example of when you start taking those things and multiplying them out. If we have 4 verbs and 4 objects, we can start to see how many different things we can describe. So we might say, hey, we want to dump memory from a process, right? Okay, we're going to read process, right? And we can describe that process with the attributes that go along with it. So we've got a language now to use. We've defined procedures. We have that language to use. How do we communicate back and forth between our teams using that language? We knew we wanted it to be machine readable. We knew we wanted it to be human readable, and so YAML was the obvious choice for us. So we're going to use that defined language to build out a YAML document that defines that procedure that we've been talking about, that UAC bypass procedure for event viewer. So this is where we'll start seeing the key, subkey, and value nature of YAML and how that really plays well into what we want to do to document these procedures. So we look at our start of our YAML document here. We've got the registry object, right? We've got our verb create, and we've got our attributes, the key, value, data, and type. So we're gonna create a registry key with the open shell command. We're gonna put in the default value. We're gonna give it the data that points to our binary on disk, and we've got a type. Next, we're going to create a process, right? We're going to start a process. So we do process create, and we list out its attributes to describe that process. So we're starting cmd.exe. It's got a process command line, so we're using an attribute called process command line, saying /c event viewer. And now we've got, notice the tabbing over, right? So in YAML, we have a subkey. The second process operation up there for event viewer is a subkey of the parent key. So we have a parent-child process relationship that we can document in a machine-readable fashion. So we can track that. cmd.exe started event viewer, and event viewer is a child process. The registry operation is a child of that event viewer. So we can see that event viewer went and read the read the registry key, same one we created before, and then created a child process, so another child process that was our malicious binary on disk. So a lot there, but if you understand YAML, hopefully it's a fairly simple idea, but that parent-child relationship is really what's powerful here for us. So we have the details of this procedure now. We can build hyper-specific emulations of this procedure, detections of this procedure. We can go hunt for this procedure, but we need to track it against other procedures on the MITRE attack framework, right? We want to map it to MITRE. We want to track the intelligence that's tied to this. So we need to go a little bit further. I'm going to create some space, just shift that stuff down so we can see in the back there. And we want to track some procedure metadata, right? Just copy paste from MITRE. Here's the technique title, the ID, the description of it. And then we're going to copy that format for procedures. So we created a procedure title, a procedure description, and then we gave it a procedure ID, which is just tacking on .001. So really it's sub techniques, right, is what we're doing here. And then we're going to add Intel metadata to it. So we want to track a threat score, right? How relevant is this to our organization? Is it important to us or not? And that's based on, and we got references in there as well, so we can always go back and look at where this Intel came from. We're going to track the threat actor, right? Is this a threat actor that my organization cares about? Different from what your organizations care about, probably. We want to track what targeted industries are there, right? Is this an industry that's, is this procedure targeted against our particular industry? Have we observed this in our environment, right? Has our incident response team actually seen this happening against our environment? And then finally, we're tagging it, so we can make use of that later on to say, hey, this is known to be used by a certain malware group or whatever tags we want to put in there.
Just real quick, one other thing too, we made sure that a lot of these are optional fields, so you're not required as an analyst to put all this data in if you don't know it. So the key part is we want to be able to build this on the fly. So if you see some information, you can build a tiny bit of it, and then as that expands, you can expand it without having to basically go through and have errors or something with it. So really try to keep it a very flexible format.
Yeah, good point, thanks. So we have a fully formed procedure document in our minds now that all of the different teams can use. So what this looks like is we're starting to build out a corpus of these procedure documents, right? So when our threat intel team gets a new piece of intel in, potentially it's a new procedure that we need to document. They can grep through this repo and say, hey, show me all the procedures that have PowerShell.exe in them, right? Or show me all the procedures. Oops, thanks. I got a little clicky. Show me all the procedures that Bumblebee, as a piece of malware, is known to be using in our environment, right? So when they find a particular procedure that we already have documented, they can stop right there and say, cool, we already got this one covered. No need to go build a report for it. No need to go do any of the extra information that's required for it, because we already have that procedure documented. Maybe we say, oh, but we've never seen Bumblebee doing this particular procedure before. Cool, let's just drop that in there, right? We add Bumblebee as a tag in there, and we move on. And that way we can continue to track how these different threat actors, different malware, whatever it is using these different procedures.
So what does this do for us? So now that we've gone through the effort of creating this YAML document, the shared language, how does that help reduce some of the time it takes? The idea is that hopefully it's reduced some of that time it takes to do that initial detection research from the hours or days that it took before to minutes. Now a detection engineer can just pick that up, take a look at it, and very quickly run a detection. All the information they need is contextualized very quickly within a very small amount of information.
So we defined our language, we've got a way to communicate it, but we need to coordinate this information in back and forth between teams. So this is a general workflow of intel through our organization, pretty straightforward. Threat intel comes in, our threat intel prioritizes it, documents it, passes it off to our emulation teams, our detection engineering teams, and our hunting teams for doing whatever processes they need to do for it. What we've set up is a Jira Service Desk. We happen to use Jira. We use Jira Service Desk to manage this workflow in our organization. So threat intel comes in, and a parent Jira Service Desk ticket is created. This Jira Service Desk ticket manages everything else that goes on throughout our environment. So the threat intel receives a story. The Jira Service Desk ticket creates a story for threat intel that says, hey, you need to prioritize this procedure, right? How important is this to our organization? Threat intel does their work and gives it a priority score. When they close that ticket, another ticket is auto-generated that says, okay, now you need to go create that procedure document. Go take that score. If it's the most important thing in your backlog, go create a procedure document for that particular procedure. When they close out that ticket, child tickets are then created for the threat emulation team, the detection engineering team, and the threat hunting team for them to go do their respective work. None of these, the parent Jira story can't be closed until all the child stories are closed as well. So that way we can track where we are actually with this particular procedure, because we used to lose track of that all the time. We think we have a detection for it, but it's still kind of in non-prod, and we haven't done all the, we haven't cleaned up all the noise from it yet, or the hunt is out there, but we haven't used it. So this way we can track from start to finish all the work that's related to any given procedure.
So what does this do for us? So we tried to parallelize the process a bit and say, let's not take our emulation team and have them wait for detection to be built. Let's build it in parallel while we're doing that activity. So really trying to reduce that time it takes and remove some of the barriers that we have within our process. The other thing I didn't mention too that I think is important is that this is an instance of one adversary I'm showing here. There's obviously dozens, hundreds, however many different campaigns that are occurring at the same time. So we're still stuck in that prioritization process right now. We're still trying to go through and say, how do we prioritize against the legion of different events that occur? The idea is that hopefully that YAML, being able to pinpoint reuse of a procedure or something like that can, again, reduce that time it takes to identify a particular campaign and then react to it very quickly.
So the last piece of this is automation. We've defined our language, we've got a communication method, we're coordinating all that work. We need to automate this stuff. In the old days, what our team used to do is we didn't have a threat intel team a while ago. We would go out and look at the MITRE ATT&CK framework and go, that one looks pretty good, let's go build that, right? And we was an educated guess, but we really were just saying, hey, we think threat actors might do that. So let's go pick a procedure and go try to emulate that for our detection team to go build detections for. We do some research on that particular procedure. We'd say, how does it work? What are the threat actors doing? Let's understand it better. We then go build the attack. Maybe we repurposed an existing tool. Maybe we used it out of the box, script kiddie style. Maybe we built something from scratch. Depends on what the procedure was. And then we'd work with our detection engineering team and say, hey, we ran the thing, did you see it? Hey, we ran the thing, did you see it? It worked, right? But it was really unmanaged and difficult to track over time. So we said, okay, well, this is annoying. Let's script this stuff up, right? So we started taking those attacks and building them into scripts. So we could say, hey, quit bugging us. We're just going to hit the button when you want us to rerun that attack. And eventually we said, oh, wait, we can just give this to you guys. You guys hit the button and go run it yourselves and leave us alone. We'd try to build in some IOCs, right? We'd say, hey, when we do this stuff, here's the tool marks we leave behind, right? You might see this process. You might see this network connection. We try to hand those over to help them get a head start on what they were building. And then we always did a fantastic job of documenting everything we did. It was really well done, and we never forgot to do the documentation at all. So perfect documentation always. So Instead, now we have our YAML document, right? All that research is done for us. All the work is done for us up ahead. We can ignore everything up here because we've already talked about it. The only thing we need to look at is the very bottom of the screen, which hopefully you guys in back can see. But it's just a simple YAML block, right? It's just a simple key that shows here's the code that needs to execute on a machine to recreate that attack. Nothing more. None of the surrounding data needs to happen. None of the building for it happens. It's what actual code needs to execute on that machine in order to recreate that attack. But how do we get this from this YAML document onto a victim machine so that we can emulate it? That's where our automation platform comes in. I could talk for an hour about this, but I'm going to do it in about 5 minutes, so bear with me. But I'm happy to chat about this afterwards if anyone's interested. So in our environment, we have EC2 instances, we have Windows boxes, we have Macs, we have Linux servers. These are all the victim machines that we want to execute code on, and we're constantly adding to that platform of things we want to execute code on. What we've done is we have turned them into GitLab runners. And if you're not familiar with the concept of a GitLab runner, it's okay. GitLab says it's software that runs on a host that coordinates with the GitLab CI/CD server to execute code managed in your repository. Whatever, GitLab. Here's what it is. It's a centralized server that can push code out onto machines in your environment and execute as system. I'm a red teamer, that's a C2, right? Like, that's what it is. So we're gonna use it that way, right? So what we do is we take that YAML document and we push it into GitLab. We take our code, we push it into GitLab, there it goes. We just pushed it. And when that code gets checked in, we have a GitLab pipeline that kicks off. I make fun of GitLab, it's awesome. So we built a pipeline that says, hey, when new code gets checked in, go parse that code, do some YAML linting, make sure the schema matches what we want our YAML to look like, figure out which platform you want it to run on, and then it goes and pushes out to that particular platform. In our example, right, we're using UAC bypass, so it goes and pushes that code out onto that platform. Before it does that, it templates it into a PowerShell template that we have that has all the surrounding artifacts that it needs. It has API keys, it has code in it, it has all the, what do we need, account data that it has in it. So everything it needs to run on that machine, right? Templates that in, pushes that PowerShell onto the runner and executes on that runner. Bad thing has happened on that victim machine. That victim machine, that runner, then pushes that code out to Slack and to Splunk. Slack, just for convenience purposes, right? We want to see these threat injections, these threat emulations. We call them threat injections. That's why the little needle. We want to see that thing ran, that bad thing ran on that machine on that day. So it gets pushed into Slack, and then it gets pushed into Splunk. And the Splunk is where the magic happens. So we tell Splunk, we say, hey, on this machine, at this date, and this time, this particular procedure was executed on the machine, and what was the status of it? Did it execute successfully? Did it fail for some reason, and my team has some engineering work to do, or did it get blocked by one of our security tools? We push that status and all that data into Splunk. Our detection engineering team then has alerts, right? And if alert fires, the first thing they do is say, hey, can I match this up with a threat emulation that executed? Did this alert fire on the victim machine at this particular date and time, and what is it, this particular procedure? If it is, fantastic. They suppress that alert, right? We don't want to bother our incident response teams. Suppress the alert and track that. In our dashboards, we have some Splunk dashboards. We track the fact that on this date and time, we executed this particular malicious activity. It was detected, or it wasn't. It was detected, and we can check box that thing, turn that box green, and say, hey, in our organization, we can confidently say that this detection works against this particular procedure. So we think that's great, but we want to make sure that we are constantly validating those detections, right? Just because it works today doesn't mean it's going to work tomorrow or the day after that. We know that our environments change constantly, right? OSs get updated. We get SIMs change the way they process data. They go from a capital letter to a lowercase letter. Like, stuff happens all the time, right? Network changes happen, firewall changes happen. So instead of doing it just on the code check-in, GitLab allows you to build cron jobs, right? And you can say, hey, GitLab, every day, 9:30 a.m., kick off this pipeline. Execute every single procedure that you have in that repository and push it out to all those different machines. So right now we're doing approximately 200 or so, right? And we're constantly building on that repository. So every day we can push those onto those victim machines, they execute, report back to Splunk, and we can have a dashboard that says, here's the state of the universe today in our organization. Here's what's effectively being detected on, and here's what's not, here's what's missing, and then we can react to that.
All right. Matt had a lot of words, but it was good. So what does that mean for us? How does that help us? Again, get to that moving left, get to the point of being close to that minutes to hours time frame. Well, by automating a lot of the work that they've done, instead of taking days to build these individualized tests, they can just add a code block into the bottom of those YAML documents, and boom, it's down to minutes. So really, again, another step, another effort to move it forward. But we're not done yet. So what's coming next? So this is a little bit speculative, but we're working on it right now. We now have a corpus of data, of structured data, sitting in a GitLab repository that could potentially be used for training. Maybe with a large language model like a ChatGPT. I didn't say AI in the title, so if you want to leave, feel free. But anyway, so what we're trying to do now is take all this corpus of information that we're seeing externally, bring it in, train the LM on it, and really have it auto-generate this data. So we believe we can have this done in the next week's time frame, very, very soon. Because we already have the data, it's existing, it lives there. I'm just going to skip by this. This is just kind of the how, but we're going to do it within GitLab, basically. So the ideal state is that then takes it and moves our time for collection and analysis, and ideally most of this process to the minutes to hours instead of the days to weeks is the end state and end goal after we've implemented all these different features. So just a quick summary. You probably do need procedures. Think about it, take a look at your environment. Validate your assumptions. Don't assume that you have coverage unless you tested it. Make sure you're automating all the things where possible. Take advantage of open source tooling. We have this YAML file we can share with people, collaborate on, things like that. Try AI, see if it works, and ask us questions. Because we're here to say, is this a crazy idea? Does this work for you? Do you have questions? Why shouldn't we do this? So please come to us, ask questions, collaborate. We're pretty open here. And thank you for sitting through it.
So we have a luxurious 8 minutes for questions if there are any. If you have a question, please wait for the microphone. Yes, sir.
Hey, thanks for the talk, guys. I'm an adversary emulation, and I thought that was really awesome. Are you going to make your guys' repo available to the public, or is that, yeah?
Yeah, I mean, I think we'll work with our organization. There's bits and pieces of it that are relevant to outside our organization. So anything that we can make available, we will. So one thing we didn't talk about was the schema validation that we think is pretty important, right? So we use a tool called YAML, written by the 23andMe folks. Anybody here, shout out, that's cool, of all teams. But it basically just says, hey, you built this YAML document. We YAML lint it, but that's just for, hey, do you have spaces and colons in the right places, right? We want to say, hey, did you, derp on threat intelligence and you wrote threat intelligence, right? We want to make sure that all that stuff matches up so that it can execute properly. So yeah, we can release our schema. Happy to release our GitLab pipeline. I think is probably perfectly okay to release. So yeah, anything that we can, we certainly will. Yeah.
Yeah, and we'll do it in the near future too. So we'll let people know. Thanks.
It's not a package that we can just give to people and say, here, go run this in your environment, right? It's bits and pieces that hopefully you can find useful. So.
Yes.
Yeah. Hey guys. Firstly, I thought the idea of running the AI on the back of it too is absolutely awesome. It was the first thing when you started talking about it was running through my head. So super excited for you guys. Love to find out how it works. I'd be going back a bit further when you're talking about the threat scoring and the additional data that you're putting in there and context around something there for your analysts. And are you regularly updating that from different sources and are you using with a vendor API to enrich it, or is that a manual input that your analysts put in if they have the time to do, or is that something that you could do?
So the threat score that's inside of the YAML specifically. Yeah, so that one, I'm trying to, maybe I'll remember the algorithm, but yeah, there's an algorithm we have for it that's based off of threats that we're tracking, whether or not we have coverage. I think there's a couple other factors to it. Some parts of it are automated, some parts are manual. I think it's still, the initial set is manual, but the next step is to make sure that just gets populated automatically based off of the data we have.
Okay.
So,
Cool. Sorry.
good question though.
Thanks.
Thank you. Anyone else? No? Okay.
Regarding the GitLab runners, what is the scope of that? Is every endpoint in the organization or a sample?
To be honest, when we first kicked off this idea, and it's gone through many iterations, right? This is just the latest and greatest, and it's literally being built as we speak. Our idea was, oh, cool, we have Tanium, right, back in the day, and so we say, oh, cool, well, Tanium's kind of malware too, right? It just goes and installs itself places, and we can go push code to it, and we're system, awesome. So we're like, oh, cool, we could let's start small, and we'll push code to these, specific victim machines, and eventually we'll just pick random machines in our environment to go execute code on. It sounds great, but it's really difficult to do, right? Because it's really hard to build these malicious, you can pop calc, right? But even if you pop calc on some random person's machine, like maybe that's not a great idea, right? And so finding ways to execute the code in a way that's going to trigger an alert that doesn't also cause, at best, like some concern on some end user's machine, we just found we couldn't do it. And so we're leaving that door open, but no, right now it's just it's a single EC2 instance out in our AWS account. It's a single Windows box that's a runner, so yeah. Yep. But there are companies' images, right? So they are tooled up with all the tools we have. They're configured with all the same GPOs and all that stuff. So hopefully they're not some weird, one-off that shows everything green, but it's not really that way in our real environment. Yeah. It's a good question, though.
Anyone else? Well, please remember to fill out the survey form. Did I mention that already? Yes, I did. Thank you very much, gentlemen.
Thank you.